Welcome to paragraph 6.3 about the treasure chests of India. In this paragraph, we are going to look specifically at the formation of minerals in the crust near India. And I would like to have a look at what mineral resources are to be found in India, which ones were formed, how India did develop itself as a continent, and at the end I would like to look at a continental shelf and what that is. First of all, the mineral resources. If you look at the map, you will see that there are many forms of natural resources to be found in India, and they are scattered around the south and the east and the west of the continent, but they're not on the north. So most of them are to be found in the lower parts of the country. And coal, crude oil, natural gas, they were formed during the Carboniferous era. That means 350 million, 58 million years to 290 million years before present. So that's a long time ago. And during this time, iron ore, manganese, chrome, and bauxite did not exist yet. So you have to note that the mineral resources on top were formed earlier than the ones on the bottom of this list, because when India moved, and I'm going to show you that later, iron ore, manganese, chrome, and bauxite could be formed because of the collision between the Indian and the Eurasian plate on the north. And when that happened, of course, parts of former sea bottom melted into the mantle of the earth, created volcanoes, that kind of stuff, and that created eventually the iron ore, the manganese, etc. During the Carboniferous, India was part of Gondwana on the southern hemisphere. If you look at this map, you can see that India is very, very low. It's just above Antarctica, and it has a shallow sea on the north. India was clamped between Antarctica and Africa, and that warm tropical sea on the north was very important because it contained a lot of sea life, plankton, shellfish, etc. And if you look at the Himalaya nowadays, you're able to find the remains of these shellfish on top of the mountains. So that will tell you that the Himalaya was once the bottom of a sea and was pushed and crushed into the Eurasian plate and created a mountain range, and because of that we can find these remains in the Himalaya. That shallow part of the sea is called the continental shelf, and I'm going to show you how that works. On that shallow part of the sea, crude oil could be formed, but only on the light blue area just above India. And how does that happen? Well, on the continental shelf itself, that is of course very shallow, there is a lot of plankton. And that plankton is very important because when plankton dies, it sinks and it creates a layer of material on the bottom of the sea. When a new layer of sediment is deposited on top of it, the plankton is being crushed and the oil comes free out of the plankton. It's just like when you use a seed of a sunflower. If you compress it, the oil comes out of the seed. And in this case, it works the same. So actually, the plankton is being crushed by the top layers of sediment, and the oil comes out. So if you have enough plankton, and if you wait millions of years, the plankton could create a layer of oil, and that oil, of course, could create gas as well. And why? Well, when the oil starts to decay, or the remains of the plankton start to decay, the same process starts as what happens when the remains of plants start to decay. and gas will emerge, and in this case gas will try to reach the seabed. It can't because there's an impermeable rock on top of it, a layer of rock which could not let the gas escape, and in that case we could take the gas out of the crust with a Yaknica, which is visible on the right, and that means that we can use it. If that layer of impermeable rock wasn't there, we couldn't have any gas because it would have escaped. So this is all about oil, and oil only could be formed because of plankton. Coal is being created by the remains of plants. And during the Carboniferous, the temperature was high and the climate was wet. So there were lots of plants in India. And they created a thick layer of peat. And the same way as the oil was formed, on top of this layer of peat, layers of sediment were deposited. And these layers of sediment are compressing the layer of peat, which changes the way it looks. It changes the appearance. So from peat it becomes brown coal or lignite. Later on it will become coal as we know it. So the compression part is very important in this case as well, and on the picture on the right you can see what happens. You can see that there's a swamp with the remains of the plants. You can see that on the second one that there's a layer of sediment on top of that, on the peat. And then again a layer of sediment is formed, and beneath that sediment there's a layer of rock. And then that gets thicker and thicker. And on the last one, on the last of the four pictures, and the fifth one, you can see that there's even some natural gas formed because of the process of the decay of the remains of the plants. So remember, please remember, that coal's been formed by the remains of plants and oil by the remains of plankton. It's very important because it's a very different way of how this material is being formed. Then India on the move, as I told you before, India was nearly compressed between Antarctica and Africa, and you can see that over here. We're zooming in on the southern hemisphere. But then something happens. When the continent breaks loose, India moves pretty fast upwards. And you can see that on the right, within 70 million years, India moved from the southern hemisphere to the northern hemisphere and collided with the Eurasian plate. And that is, when you're talking geologically, pretty fast. And what happened was that it collided with the Eurasian plate, and because of the compression, the Himalaya was formed. So this mountainous area could only be formed because of the fact that it collided with the Eurasian plate. And of course that created some of the minerals that we were talking about in the first slide. Fast development, yes. Because of the fast development, the industrial development of the country, mineral resources are needed. And that has negative results. Of course, it's exhaustion of the soil. There's a lot of environmental pollution. You can see that on the pictures. And I see that the picture has moved a little bit, but I know what is underneath it. India has to buy crude oil from the states in the Middle East. But we were just saying that India created oil because of that continental shelf, which was on the north of the continent. Where's the oil gone? I mean, it should be there because it was formed in the Carboniferous. We'll show you that later. India invests in Africa, they trade in mineral resources, so there will be no shortage. In that case, they could get on with the production. Back to the reason why there is no oil anymore, or not a lot. You have to look at this picture. You can see the continental shelf, which is the shallow part of the sea, and you can see the coastal plain, which is the north coast of India. When India moved northwards, as we saw on the slide before the last, it's collided with the Eurasian plate. So that means that this continental shelf was compressed as well. And that means that the layers of oil that were there, formed during the Carboniferous, probably have been compressed or pushed underneath that continent of Eurasia. And probably there will be some oil there, but we just can't reach it because it's way too deep. You might know the Mount Everest is about 8 kilometers in height. That means that the crust is even 8 kilometers thicker underneath it. So that means that in some cases the oil could be probably 15 kilometers underneath the top of the mountains. Well, in that case, you're not going to get the oil out of the ground because it's way too expensive. Okay, so that was it. I hope that you got an idea of the mineral resources in India and how India works.